Just a little bit about myself. My name is Adrian. I'm working at Aspect, so I have about 18 years experience. And I want to talk to you today about our story, our experience of migrating a legacy system to a cloud-based solution. So about a year and a half ago, myself and two colleagues, we got ownership of a legacy system. So I don't know how many of you guys have had been given ownership of a legacy system and the kind of choices that you need to make. I see some people nodding in the audience. So the kind of choices that you need to do in terms of migrating to a new system. So in our case, it's a billing system, so it's a critical system in terms of the end of month. Bills need to go out to customers. They need to be accurate. They need to be on time. So our system, it's a very simple idea. So let me just talk to you a little bit about that before we go into actual some of the choices that we needed to make. So our system, it runs in a data center. There are many different types of call servers, and each one of these aggregate messages to a more central message broker that queues messages. Then there's a metering process that captures the raw messages and stores them in a database unrated. Later on, there's a process that runs rating and reporting, and this calculates the charges, and these charges or these reports get sent to a FTP server that the customer can access. So it's a very simple idea. It's a system that runs in multiple data centers. There's lots of different call servers, so something like 140 call servers that we have to aggregate messages from. So why do we want to migrate this system? It's a simple system. Firstly, the system's about 15 years old, and over time traffic has increased. It's increased to the point that the core part or the database, it can't write fast enough. So we can't get the records into the database as quick as we want in terms of the traffic coming in. So this leads to a lot of component failure. We constantly have to restart components. So the metering component, the message broker component have to be restarted. And this pressure causes other parts of the system to build up that ends up writing messaging to disk. So the raw billing records get spooled to disk out on the call server. Then on the other side, in terms of rating and reporting, it's slow read. So over time, the system has just got slow. It's failed to keep up with the increased traffic that's starting to come through the system. Also as well, reason number two, it started off simple. It started off like this. Message version 1 went through the system. But over time, other parts got built out. So we supported a different message type. But the first message type never went away. Those components were still active in production. And there was a third one when we brought in SMS messaging. This part of the system was built out, and the older parts never went away either. Also as well, there was a lot of system variances. So because there was so many servers, there was 140 servers, like I said, or more than that, each one was configured slightly different. There was slightly different configurations. So it just got very hard to manage in production. It got very time consuming. So this is just a breakdown. So I took sprint velocities and what we were covering per sprint. So at a base level, there was 20% of our time being spent on internal queries or customer queries. Because the data was unrated in the database, every time a customer queried a bill, we had to rerun our rating process again to make sure it matched up. So it was time consuming. So there was automatically sprint per sprint 20% that we were spending on that kind of activity. There was also other points. So because the system was older, because it was creaking. We spent a lot of time. There was 45%, 60% on various high queue activities, restarting components. There was some outages that we had to back up and so forth. So there was a lot of manual intervention, and sprint by sprint, our velocity, we weren't able to achieve as much as we want to achieve. So we spent a lot of time maintaining the older system. And also as well, because of the nature of the business, we couldn't support the business needs. There were certain third-party applications that we were using that required usage, that we needed to know their usage, that we just weren't able to support. We didn't have all the data. We weren't able to run those reports. So just over time, we weren't able to cover some of the needs that the business had. So there are 4 reasons why we thought, or we wanted to migrate. So now, once we'd made the decision, or we had our reasons why we wanted to migrate, the next question was, how were we going to go about and do this? So some of the options we looked at, there's a discovery phase where you need to understand what your system is and make a plan for it. And it's not always technical either. You can understand how the components work. You can understand what they're doing, where the messages are going, but there's also a process, or the business processes that you need to understand as well. So in a lot of cases, the choices that we had to make and the plans that we put in place were there were outcomes of the process as well, or what the business expectations were. So the 4 type of paths that we saw that potentially we had was the idea of a rehost. So we take what we have, we lift it and shift it to the cloud. We re-platform, we take what we have, we integrate it into the cloud, we swap out some of the layers, we make it work with the cloud. So that's the lift and replace idea. There's a repurchase idea where we could have gone out to a third-party vendor, and that option had been explored, but it wasn't on the table for us because of the custom rating logic, some of the custom features that we had. No one could replace that in the marketplace. And then the 4th one is to re-architect the solution. So that's what we did. That's what we looked at. So I'm going to talk about that over the next set of slides. So we came up with an idea. The idea didn't spring to us overnight. We prototyped, we iterated, we had a look at a lot of different types of technologies. And as I mentioned earlier, it's not always the technical side. We have to work on some of the processes that's in the business. We have to look at those, we have to understand those, and some of the choices were based on that. So the idea we came up with was that we're going to link into the older system. We want our new system to run in parallel with the older system. So we want to be able to stand it alongside to prove out its viability. So the obvious entry point for us was to start at that message broker point, that we can split the messages at that point. So this was the bridging, what I call the bridging part of our solution. So we were then going to send those messages into a data stream, so Kinesis data stream that can hold data for up to 24 hours or beyond if that's what your needs are. And then a Lambda to consume those messages and stage the information in a Dynamo table. So we looked at this piece of technology first. We looked at the Dynamo part because if you remember back to the problem was we couldn't write fast enough. So that's the first thing we looked at. We looked at, can Dynamo scale to meet our needs? Can it write fast enough into a table to stage the messages that we need? The Then in terms of getting those messages from the table, we needed a way of applying rating like before. And again, there's a subtle difference. Before, we had a rating and reporting coupled together, but we wanted to separate that. We wanted rating and to store the rated data. So you remember in the earlier solution, we were storing unrated data. We wanted to store the rated data this time to help us speed up in terms of internal and customer queries. So we didn't just want to build a system that was equal to the previous one. We wanted to fix the issues. And one of that was to store the actual rated data. So I'm going to be looking at this part in more detail over the next couple of slides. Very early on, so I mentioned about a year and a half ago we started looking at this. So we started actual production code, writing production code in last January 2018. One of the first things we did was build a Jenkins pipeline that allowed us to deliver our components straight to production. So, and this was to fix that problem that I mentioned earlier on, the system variances. We wanted to be able to roll out a consistent system each time to production. And we iterated. So I mentioned we re-architected, but it's not 100% true. What we actually did start off with was the lift and shift. And gradually, we started to look at lift and replace. Because going straight to a re-architected solution, it's challenging and difficult in one go. So what we did was we took the original component. This is just an example of one of the components we had in our system. So we took the original component, we containerized it, we took out the original database layer, and we made it work with a cloud database. So that's the lift and replace strategy that I talked about in the migration paths earlier. So we iterated. We wanted to keep, once we started down this path, we wanted to build something and keep it running in our system. So then we started to separate out logic. We started to remove independently deployable parts out of it. So we removed our staging logic, the conversion between certain messages. So our SMS support, our call support, those message support. So that message 1 and 2 and 3 that I talked about in the earlier slide. And in fact, we went a little bit further. We decided we wanted to get rid of path number 1 and consolidate it down and streamline what we were doing. So this was an iterative approach. So we separated out the logic and we continued on that. Then we built failure handling. We built failover, that when we couldn't send a message, for example, to Kinesis stream, that it would send it into an SQS queue. And we built failover in case that failover didn't work. So we built 2 levels of failover because I'm a little bit paranoid. So we wanted to make sure that if we couldn't handle messaging, that we would definitely capture the raw data somewhere. Then we looked at each point on our system. We looked at where the problems may be. Is it in transactions? Is it where we can't send something to the error queue? And in particular, we looked at when we're consuming messages in our Lambda, so that's point 5, we're looking when we consume messages in our Lambda that we can consume them quick enough and write to DynamoDB. So that part was scaled up and worked. So we looked at all the failure points and we built end-to-end testing to verify that. Then we tried to break everything. So I don't know if anyone here has tried something like a game day. Well, we did. So the 3 of us, so there's 3 of us on the team. So we went into a room and we wrote down what we thought would happen when we broke something. We built the monitors and then we did it. And in a lot of cases, it turned out to be different. The things we thought might happen happened in the wrong order. So it was very interesting for us. So we did this by building message drivers through the system. And for the first time, I think it's pretty exciting. I really love performance testing and driving things through a system to see where it breaks. It's really exciting for me. And I think for the first time in my career, because we can Dockerize things, we could Dockerize message drivers to the point that we can hit it with any amount of traffic that we wanted, more than so it's back to the old days of borrowing people's laptops and machines around the office to see can you stress test the system. But anyway, so we Dockerized our message drivers, and we basically pushed data quickly through the system. And we introduced chaos testing around that, so automated chaos testing. Again, part of the pipeline, we could enable things in our pipeline to roll these out into our staging environment to run these tests. And like I said, things happened differently. And it was a very interesting experience because we brought back the feedback, we fixed the issues that we found, and we made better monitors. So at this point, we felt we had built a good system. We were ready to put this alongside our existing system. We knew the scale of what we needed to match. We had a profile in terms of the traffic coming through on the older system, so we knew exactly what we needed to match. So we were in a position to start that process. And this is what really happened. So we had a data center outage. This happened at the point where we were waiting for some tickets to get cleared for us in order to build SSH tunneling back to our original system. So in order for us to connect to the legacy system and stand it up side by side. So as soon as the data center outage happened, these tickets got automatically cleared, they were accelerated. We were able to get those tickets cleared. So, but we had a choice to make. So in terms of the outage, it was a leak that happened. And I think, as we all know from physics class in school, that water and electricity doesn't go too well together. So a lot of servers had to get powered down in the data center. We didn't know how long it would take. We didn't know what kind of effort. So recall back when I said that the system variance in terms of what was there in production versus what we had in our code base, we simply didn't know what kind of effort it would take for us to rebuild those particular servers. So we had a choice. Do we resuscitate this thing? Do we try and bring back our systems? Or do we roll out? So we rolled out our new solution. We rolled it out. It wasn't ideal. We rolled out the new solution with the bridging part as well. That's what we tested. But now we weren't going to stand it alongside the older system. It was actually going to replace our older system. But we rolled it out because that's what we had tested. We used Jenkins to, as indicated earlier, with our CD pipeline, and we used Chef to roll out our queuing mechanism or aggregation part. This is the part that got the messages into the back end. We spent a bit of time, actually, we spent about a day getting some of the tagging right to make sure it was all okay. And because one of the things is we wanted to have accurate monitoring to take a look and gauge the system. And we found a problem. There were 3 call servers at this point, and we noticed there was a bottleneck. Because one of the components we lost was the ActiveMQ, the bridging part, we had to build that somewhere else. And that actually, latency was causing a bottleneck, just indicated by the arrow there at that point. There was a build-up of messages on 1 or 2 servers that it wouldn't have scaled out. So I think just back to one of the other presentations, it was Joe who mentioned this simplicity idea. I said it wasn't ideal that we rolled out the bridging part, but that's what we had tested. But was it the most simple solution we could have rolled out? It wasn't. It didn't serve our needs. So we removed ActiveMQ because it was only ever a bridge to getting us between the legacy world and the new system. So we removed it. We had this QD component. We rewrote this part, or rewrote the connection part, that instead of sending it to ActiveMQ, it sent it to Kinesis Stream. So again, just back to our migration path, we couldn't have done this if we'd lifted and shifted and waited at this point. Because we had gone and decoupled and removed logic out into lambdas and microservice architecture, we were able to do this. So we made incremental improvements. So we rolled out an encryption fix when we found messages were coming to us encrypted. We rolled out better tagging for monitoring, and we provisioned more services. And again, this was all done via the CD, the continuous delivery pipeline. Then we hit a major data issue. So while we had profiled the messaging, there was a lot of messaging coming through the system. There was one thing that we didn't pick up on. It was that one of the biggest customers that we had using the system, there was an issue with a timestamp. So it turned out that their servers were specially patched. And again, this goes back to your testing versus production. Things are different in production than in your test environment. So we couldn't process their data. We didn't panic. We built a failsafe so we could fix it. And we fixed it. So how do we fix it? What we did was we split the messaging and we added a new component. It wasn't an add-on, so we built a specific component that when this customer was migrated away from their servers or upgraded at some point, we could take away the component. It wasn't some add-in piece of code. And at this point, we were capturing data. So all these events that I talked about, it's a summary really of our journey within this time frame. So from the outage on the 28th of April, we were capturing data in our new system in about 2 weeks. So where are we now? In terms of our system, so there was other parts. So we continued to build out rating, and we continued to build out reporting. In terms of those issues that we have, that I mentioned earlier, we had that variance problem is fixed. We're able to scale. In fact, in July and August, we hit traffic levels not seen in the older system. So we were able to scale the Dynamo tables, scaled up in terms of the traffic there. So we were able to handle that. And in terms of team capacities, well, we're not answering, we're quicker when customer requests come in, and we don't have that overhead like we had before. So our thoughts, I don't think we could have accelerated our recovery if we hadn't been set up for continuous delivery, and we were prepared to fail. I talked about this. We'd built a failure support mechanism into our solution, so we could identify the problem when we had fail-safes when we failed. When we didn't get it right, we could fix it. So when we hit the issue with the timestamp, we were able to roll out very quickly a fix. And we always controlled how we worked. There was a continual reprioritization of resources and efforts, even when it got challenging. We never panicked for one moment. And we could affect change directly in production from our pipeline. So anything that we needed to do in terms of changes, we were able to do them. So thank you very much for listening today. That was our story of our experience of migrating from a legacy system to a cloud-based replacement.